Precalc 3.2 logarithmic functions. So, the first thing we should talk about is switching from log form to exponential form. So again, log form is log base b of x equals y. And then we have exponential form. And exponential form would be b to the y equals x. The biggest thing about this, guys, is that you need to realize that this goes in both directions. You can interchange these forms at will. Doesn't matter. So you will use the one that is most beneficial to you at a given time. So the first thing I would like you guys to do is just switch between the forms. So, here we go. What if I gave you 2 to the third power equals 8? Can you switch that to a log? What if I gave you log base 4 of 64 equals 3? Can you switch that to exponential? Please do so now. What would you do for the 2 to the third power equals 8? How would I switch that to log form? What would it look like?
Log 2 to the 8th equals 3.
Log, now remember, all our positions are in certain places. So when we go here, the base of our exponent is the same as the base of the log. The exponent of the log, or the exponent of the exponent, is what the log equals. And the number that your exponent equals is the number that goes inside the log. It's because logs are just a fun way to express exponents. And what we're going to see starting tomorrow is that logs will follow the exponent rules. It's just a different way of representing things. So yes, this would be log base 2 of 8 equals 3. Now, it's very important that you understand this, because that means that if I ever saw a log base 2 of 8, I could basically substitute its value, 3, in for it. It's really kind of cool that way. Same thing over here. If I see log base 4 of 64, I can replace it with a 3. But why? Why is that true? It's true because what would the exponential form look like of the second one? 4 to the third power equals 64. And is that true? 4 times 4 is 16. 16 times 4 is 64. So it works out just fine. So now, what they're going to do now is that we're going to say, hey, there's some other ones here that I want you to evaluate. And this time, I'm not going to give you what they're equal to. I want to give you a log, and I want you to just evaluate. I can't solve, because there's no real true equal sign, but just going to simplify. So the first one is log base 8 of 512. Next one, log base 4 of 4 to the 32. Next one, log base 2 of 1 over 32. And the one after that, 16 square root of 2. So, right now, I want you guys to think about these with what we just talked about, potentially switching it. Think about it, we'll pause it, come back to this in about no time for you. Top one, log base 8 of 512. Now, these are not equal to anything. The only thing I can do is evaluate, aka simplify. I can't truly solve it. But hopefully we recognize that if I have a log form, I could technically switch it to exponential as long as it was equal to something. So arbitrarily, do I know what this number is right now? So arbitrarily, I'm just going to say, hey, what if I made it equal to x? Now, could I switch it?
Yeah.
Oh, so then you'd be like what? 8
X.
to the x power equals 512. Now, could you take your calculator out? Maybe you didn't need your calculator. 8 to the first power is?
8.
Oh, it's not 8 to the first, so it's not 1. How about 8 squared?
54.
That's not it. 8 to the third power
512.
is 512. So therefore, x is equal to? 3. Now, when I say x is equal to 3, remember that x was actually log base 8 of 512. So I wouldn't write x equals 3 technically. I would understand that this whole entire thing is 3. Log base 8 of 512 is equal to 3. Do the same thing now with that second one. Maybe we don't understand how this simplifies. So set it equal to something. Could I let this equal g? I could if I wanted to, right? So couldn't I say that this is 4 to the g power is equal to 4 to the 32nd? Wait a minute. If the bases are the same and these numbers have to be the same, the g has to equal 32.
Wow.
Kind of interesting. What about the next one? Now they're going to start getting a little bit tougher. I'll use x. 2 x equals 1 over 32. Ooh, this one's interesting. So 2 to some power is equal to 1 over 32. Hey, wait a minute. 2 is a nice whole number, yeah? I eventually got to create a fraction where my number goes to the bottom. Wait a minute. What exponent rule takes things from the top and drops it to the bottom? A negative. So you're saying that if I have a negative number as an exponent, it would have to move to the bottom. So the next thing you have to think about is, can I make 32 on a base 2? 2 to what power is 32?
Ooh, negative 5.
5. So x would have to equal negative 5. So some of these we just got to think our way through. That is a 2. So it's log base 16 of the square root of 2.
That makes way more sense.
So now, I'll let this equal x. So 16 to the x power is the square root of 2. Now we have some issues. The first issue is the fact that I have a square root of 2. If obviously, yes. Think of this. Everything else is exponents. Why do I all of a sudden just have square roots? Yes. Roots, guys, can be written as fractions. And square root is the same thing as what power? It'd be 2 to the 1/2. So this becomes 16 equals 2 to the 1/2 power. That's 16 to the x. Wait. 16 to some power is equal to 2 to some power? Wouldn't it just be easier if I could get the base numbers to be the same? And can 16 be written as the same base as 2? What is 16? It's 2 to the 4th power. So if I took 16 out and I put 2 to the 4th, I still have an x hanging out there. 2 to the 1/2. And what do I have there? I have power of a power. And power of a power, you? Not add. Multiply. So I get 2 to the 4x equals 2 to the 1/2. If the bases are the same, the what have to be the same? The exponents. I'm going to put it up here. So that means 4x equals 1/2. Get rid of 4i. divide by 4. Now, that means I would have to divide a fraction by 4, which is 1/8. Would there be a possibly an easier way? Instead of dividing, could I multiply both sides by something? Multiply by the reciprocal. So I'm going to multiply by 1/4. Because when I multiply fractions, I can multiply cross. 1 times 1. 2 times 4. And I get 1/8. So x is equal to 1/8. Questions? So we're going to talk about the properties of logs now. There are 4 things that you guys, on those last couple problems we did, if you guys would have known this first, probably would have made it a lot easier for yourself. Like log base b of 1. It's log. Log base b of 1 equals something. Log base b of b equals something. Log base b of b to the x. And log, or b to the power of a log base b of x equals something. And so, log base b of 1. Now let's use some of the same thinking as last time. That if I let this equal x, guys, that means b to the x power equals 1. Well, b to any power, or any base to this power is equal to 1. 0. And so I need to take away x. I actually got to put 0 there. Because log of any base of 1 is 0. Here's a really cool thing. Log base b of b is equal to 1. Because b to what power is equal to b? 1. Think of this. B to what power is b to the x? X. So this one equals x. Bless you. And using the same reasoning, if I let the log become an exponent on a base with the same base as the log, they will cancel each other out, leaving you with x as well. Guys, the first one is log base 9 of 81, and then the second one, 3 to the power of log base 3 of 1. Guys, because I showed you guys the 4 little properties on the last slide, I'm hoping we don't have to sit there and say, okay, where does log base 9 of 81 equal x, and then switch it. You should maybe go and say, wait a minute, 81 can be of base 9 because it's 9 to the, yes, 9 squared. If the bases are the same, they cancel each other out, leaving you with 2. That's it. So the log base 9 of 81, you can switch it out with 2, because that's the answer. That's what it simplifies to. Log, or 3 to the log base 3 of 1. The bases are the same, cancel, equals 1. Done. That's how easy these things can be. It doesn't matter what's in this position. If I had something like 4 log base 4 of 2x minus 8, the answer would be 2x minus 8. That's a bad equal sign. Okay? Because if these bases cancel, I just wrote it up here. This position here, inside the log, is your answer. Next thing we want to talk about are common logs and natural logs. So, common logs and natural logs, they are on your calculator. They're the only ones that are truly there. Some of our calculators can handle some other bases. But We also, as mathematicians, got a little lazy. We wanted to stop writing this, log base 10 of x. And so we changed it to log of x. We omitted the 10. It's implied. Just like when you have a square root, what really should be tucked up in the top corner there? A 2. You don't see it, it's implied, it's a square root and not a cubed root, right? Because cubed roots have a little 3. Natural log, they did not want to keep writing log base e of x. And so they use ln x, which is natural log. So we got common log and natural logs. They are both on our calculators. And so all we have to do now is do a little bit of work with logs and natural logs. So this is our work for the common logs. Now common logs, guys, follow the same 4 basic properties that were given on the slide from before. Just instead of using b, they have 10 there. So use that idea. That way maybe, hopefully, we don't have to set these equal to x and switch it. Where you can instead get the bases to be the same. And if you need to, it's okay to change it from log 10,000 to log base 10 of 10,000. Then obviously you're going to want to change 10,000. So, what is 10,000 as a power of 10? Because it really becomes log base 10 of 10 to the, how many zeros? So it's 10 to the 4th power. And so these will cancel away, leaving you with 4. Log of 10,000 is 4. You can replace those anytime you would like. Log of 0.081. Sydney, what do you get?
Oh, I was not doing that.
Not that one. Because you have to use your calculator for this one. Because you're really asking yourself, 10 to what power is 0.081? It would, yes. Equals negative 1.09. So make sure to take your calculator out and find the log button so you can put this on there.
Okay. Do we just have to plug that in?
Yeah, this one just evaluate it on your calculator. Really quite nice.
Yeah, I didn't get that.
You did not get that. Because remember, guys, we could test this. That means 10 to the negative 1.09 should equal 0.081. Guys, the third one, people are getting errors. Because it does not work, not a solution.
No soul. Negative.
Think of this. This would be a 10, yes? We don't know what it is. Let's actually do this method here of calling it equal to x. So what power on 10 is equal to a negative number? Can you take a positive base to any power that will result in a negative number?
No, sir.
10 times itself, no matter how many times you want, will never become negative. Therefore, no solution. There's an error. Can't do it. What happens with the fourth one?
We do log
Cross it out.
Cross it out equals 3. Done.
So this is natural.
So now we got to deal with natural logs. I want you guys to take a few seconds here. Try to evaluate these. Some of these you can do without a calculator. Some of them you will need a calculator. So the first one, it's e to what power is equal to 32. Since I don't think it turns out to be a nice number, first of all, e is not a nice number. I will rely on the calculator. I will type in 32 natural log if you're using a gray standard box. Or if you have the graphing calculator, hit natural log, type in 32, hit enter. You end up with 3.46 la-ti-da-ti-da because it goes on forever. Guys, we can check our answers by saying e to the 3.46 power should be really close to 32. Hey, wait a minute. E to the natural log of 4 power? It's just 4. Because remember, natural log is log base e. They're gone, so it equals 4. Those are nice. Natural log of 1 over e to the 3rd power, though. It is -3, but how do we figure that out? It's exponent rules. This thing is in the basement, which means to get to the basement, it had to have had on top a negative exponent. So therefore, this should have originally started off with as e to the -3 power. We didn't like negative exponents, so we threw it to the basement. We bring it back top, it's a -3 again. And those will cancel, leaving you with -3. And the last problem, does it exist?
No.
Yes, it does. Order of operations, guys, says you need to do the natural log first. Then multiply by -1. So it's a -2.19. So tomorrow you're going to get your log packet, your log of logs, and we'll be working on that.